Greetings of the day. Today we will discuss some more about this circle related with what are the circles are connected, that is in circle, circumcircle and then orthocenter, these all things we will see, and then its questions we will be discussing it. So now we know already circumcircle. Circumcircle means a circle outside the circle circumscribing a triangle. So from there you know that as the sine rule formula, that is A by sine A equals B by sine B equals C by sine C equal to 2R. From there we can write this as A by 2 sine A equals B by 2 sine B equals C by 2 sine C equal to R. That is R is a circumradius. Now you multiply and divide by BC, so it will become ABC by 2 BC sine A R ABC by 2 AC sine B equals ABC by 2 AB sine C equal to R. So we know that as half BC sine A is area of a triangle. So we get this one as ABC by 4 del equal to R. That is the circumradius in terms of the side and a triangle. Then let us move into the next in circle. In circle the radius R equal to del by S R. S minus A into tan A by 2, it is same as S minus B into tan B by 2, it is same as S minus C into tan C by 2. This formula also we get for this. Now from this R equals, we can get 4 capital R sin A by 2 sin B by 2 sin C by 2 we get. Then this R value, this is less than or equal to 4R into 1 by 8, since sin A by 2 into sin B by 2 into sin C by 2 is less than or equal to 1 by 8. From this we get R is less than or equal to 2R. That is the relation between the in circle and a circumcircle. So in circle means what? The circle is inscribed in the triangle, and the circumcircle means the circle is outside the triangle. So now you have this one as the in center, that is I, and the circumcenter we get the radius S equals. So this is your capital R and this is your small r. So these are the relation between this one. So the equality holds, that is equal sign holds it when triangle is an equilateral triangle. So if you have an equilateral triangle, then you will get it as R equal to 2R. Now let us see that as what is the distance between the in center and the vertex. In center and a vertex. A, B, C, it is your in center. So we want to get that as what is BI. So this we know R. So this one is B by 2. So if it is B by 2, what is BI? So this we know that as 90 degree. So BI we want means we can take sine B by 2. So sin B by 2 is, you get this one, let us take D. So ID upon BI. So ID upon BI. So ID is what? R. R by BI equal to sin B by 2. BI equals R by sine b by 2. So, this is the distance of this vertex from the incenter. Similarly, we can say that ai equal to r by sine a by 2 and ci equal to r by sine c by 2. This is the distance of the incenter from the vertex. The next one, what is the length of the angle bisector? How to find the angle bisector? We know that as this is the angle bisector, that means a by 2, a by 2. Now, from this a, b and c. So, if you take this one AP as the angle bisector and your incenter lies on this. Now, from this we get AP equal to 2BC by B plus C cos A by 2, and similar way if you have the another angle bisector, that is BR. So, BR is equal to, you get 2 AC by A plus C cos B by 2, and then another one if you have CQ, that is another angle bisector, CQ equal to, you get 2AB by A plus B cos C by 2. So, now these are the relations in circle. Now, let us move into the ascribed circle. Ascribed circle means a triangle, a circle touches the three sides such a way that then its center I1, it is your angle A, B, C. This is your triangle. It is touching to side BC and extended AB and AC at some point P and Q. Now, what will be the radius? This you have R1, R1, R1. Okay. So, now what will be the radius R1 equals? You get R1 is equal to del by S minus A, or it is same as S tan A by 2. You get S tan A by 2. R you get 4R sin A by 2 cos B by 2 cos C by 2. This is your ascribed circle opposite to angle A. And similar way, opposite to angle B, you can draw the circle that will be ascribed about opposite to B. Similarly, opposite to C also we have it. So, now R1 is okay. So, R2 we get, that is del by S minus B, that is same as S tan B by 2, that is equal to 4R sin B by 2 cos A by 2 cos C by 2. Then R3, that is another circle opposite to C angle. So, that gives us del by S minus C, S tan C by 2, that is equal to 4R sin C by 2 cos A by 2 cos B by 2. So, these are the relations. So, we have it. Now, we got R1, R2, R3. Now, what will be R1 plus R2 plus R3, that is equal to 4R plus R we get. Another one, R1, R2 plus R2, R3 plus R3, R1 equals, we get R S square R R1, R2, R3 by R we get. So, these are the relation between the ascribed circle. We have the sum of, that is R1 plus R2 plus R3 equals 4R plus R, and R1 R2, that is the product of 2 taken at a time. So, R1 R2 plus R2 R3 plus R3 R1 is equal to S square, that is equal to R1 R2 R3 by R. So, these are ascribed circle and in circle. The next one, orthocenter. Orthocenter means what? where the altitudes of a triangle meets at one point. That point is called orthocenter. So that means you have a triangle here. The altitudes of the triangle meets at a H. So this point H is called an orthocenter. Now from this, what is the length of AH? The vertex is, what is the distance between the vertex and the orthocenter? That AH is equal to 2r cos A, where r is the circumradius. Similarly, BH is equal to 2r cos B and CH is equal to 2r cos C. Now, let us see question 1. What it says. You can read in your models also. So now in a triangle ABC, the in radius and 3x radii are R, R1, R2, R3 respectively in usual notations. The value of R into R1 into R2 into R3 is equal to what? So we know that as R equal to del by S and R1 equal to del by S minus A, R2 equal to del by S minus B, R3 equal to del by S minus C. So if you take the product of this R into R1 into R2 into R3 will give us del power 4 by S into S minus A into S minus B into S minus C. We get. So now we know that as area of a triangle, that is a hero's formula, that is S into S minus A into S minus B into S minus C. So if you square it, so you get del square is equal to S into S minus A into S minus B into S minus C. Now if you replace this value here, so the product will give us del power 4 by del square, that is equal to del square. So we get R into R1 into R2 into R3 is del square. Now you can see the options 2 del, R del square, R A B C by 4 R none of this. So your option is B is the correct option. Now let us read the question number 2. In this we have that as the distance between the circumcenter and the orthocenter of a triangle ABC is these options given. Now we have to find out the distance between the circumcenter O and the orthocenter H. That means what is OH length is what that we have to find out. So now in this we know capital R and it is a circumcenter, therefore if it is a C, then this also C and this also C. It is 90 degree. So therefore this angle become 90 minus C. You get. Similarly, angle DAC, this is 90, this is C, so this angle also 90 minus angle C. So now we have this and this. This whole is A. So we can get what is OAH. What is OAH? Angle A minus this 90 minus C and then minus another 90 minus C. So this we get angle A 90 minus 180 and then plus C plus 2C. This whole is angle A. In this we have taken, because this is C, so this is 90, this automatically it becomes 90 minus C. Similarly, in this triangle you have this is C and this is 90, so this becomes a 90 minus C. So now from A, if you subtract it OAH we get. So OAH is equal to angle A minus 90 minus C and minus 90 minus C. So minus 90 minus 180 and then plus 2C we get. So from this we get angle A plus 2c minus 180. But we know that as it is in the triangle, angle A plus B plus C equal to 180 plus 2c minus A minus B minus C, or this you get C minus B because A get cancelled and the 2c minus C is C. So, C minus B we get. Okay. So, now what is AH is equal to 2R cos A. Already we have seen that 2R cos A. This length is 2R cos A. Now, we get angle OAH is equal to C minus B. Now, let us apply the cosine rule. In triangle OAH. Okay. So, this one we know R, this one we know 4R cos A. We want to find out OH is what. So, OH is what means what we can get? OH square. OH square is equal to OA square plus AH square minus 2 OA AH cos of angle OAH we get. So, from this we get OA square, that is R square, plus 2R cos A, that is 4R squared cos squared A, minus 2 into R into 2R, that becomes 4R squared cos A cos C minus B, because we have angle OAH is equal to C minus B. So, now from this we get R square plus 4R squared cos A into cos A minus cos of C minus B. Further, R square plus 4R squared cos A cos of pi minus of B plus C minus cos of C minus B. So, from this R square plus the 4R squared cos A into minus cos B plus C minus cos C minus B. So, R square minus can be taken out. So, minus 4R squared cos A. Now, this will give us cos B plus C plus cos C minus B. So, this will give us R squared is out, 1 minus 8 cos A cos B cos C, that is equal to what? OH square. So, OH is what? R root of 1 minus 8 cos A cos B cos C. Now, let us see the options what we have here. So, R into root of 1 minus cos A cos B cos C. So, this option is right. The next one, it is 1 plus, it is not. Another one, 1 minus 4. So, it is also not, and none of these also not. So, we have the option A is the correct one. Now, the next question what it says. It says that as the radii R1, R2, R3 of ascribed circles of the triangle ABC are in HP, that is harmonic progression. If its area is 24 square centimeter and its perimeter is 24 centimeter, then the length of its sides are what? That is, we have to find out what is the side A, B and C. So, now given that as R1, R2, R3 are in HP, R1, R2, R3 are in HP. So, what is the value of R1? R1 you know that as del by S minus A, del by S minus B, S minus C are in HP. So, if they are in HP means their reciprocal are in AP. So, therefore, S minus A by del, S minus B by del, S minus C by del are in AP. Okay. So, now if you have this is a constant, so we can say from this S minus A, S minus B, S minus C Rn AP, or in other way around A B C Rn AP. So, A B C Rn AP. A B C Rn AP means what we can say? So, 2B equal to A plus C. Now, we are given its perimeter. The perimeter means what? A plus B plus C equals to 24. So, A plus B plus C equal to 24 and A plus C equal to 2B. So, we get here 3B equal to 24 or B equal to 8 we get. So, now we got the value of B equal to 8, and what else is given? Area is given. So, area means what? So, del equal to 24. Del is what? Root of S into S minus A into S minus B into S minus C equal to 24. So, before that, what is S? S already given, that is the 2S is given, 24, that is the perimeter is given. A plus B plus C is 2S. So, therefore, S is equal to 12. Now, S equal to 12 we got, already we got B equal to 8, and we have a relation between B, A, C, S to B equal to, so therefore, A plus C equal to 16 or C equal to 16 minus A. This value we can replace here. So, from there if you substitute the values of S, B and the C value, we get an equation, a quadratic equation. So, from there 48 into 12 minus 12A minus 48 minus A square plus 4A equal to 576. This is 48 and this can be cancelled. That is, you will get 12. So, 12A or minus A square plus 16A minus 48 minus 12 equal to 0, or you get A square minus 16A plus 16 equals to 0. So, if you factorize this one, you get A minus 10 into A minus 6 equals 0. So, A minus 10 into A minus 6 equal to 0. So, A equal to 10 or A equal to 6 we get. So, when A equal to 10, you will get C equal to 6. When A equal to 6, C equal to 10. So, we have either 6, 8, 10 or 10, 8, 6. These are the options of the length, that is A, B, C can be 10, 8, 6 or 6, 8, 10. So, these are the options of the length we get. So, what we have done, we have taken R1, R2 values, R3 values, their simplifications, it is given HP. So, we know that their reciprocal becomes AP. So, from there we got a relation of 2B equal to A plus C, and then area is given. So, from that area we got an equation, a quadratic equation in A, we factorized and we got the value of A. So, corresponding that B and C also we got. So, the options A, B, C are 10, 8, 6 or 6, 8, 10. So, now you can see that what are the options you have here. So, here 6, 8, 10 as the option you have it. In triangle ABC, the value of R1 plus R2 upon 1 plus cos C is always equal to what? So, we know that as R1 plus R2 upon 1 plus cos C, we have to see that. So, R1 plus R2, R1 is what? 4 R sin A by 2 cos B by 2 cos C by 2 plus 4 R, we have R2 is sin B by 2 cos A by 2 cos C by 2. Now, from this what is common? So, 4R into cos C by 2 is common. So, cos C by 2 into, you get sin A by 2 cos B by 2 plus sin b by 2 cos a by 2 we get. So, now 4r cos c by 2, it look like sin a cos b plus cos a sin b. So, that is sin a plus b format. So, therefore, sin of a plus b by 2 we get, or 4r cos c by 2 into, we know that as a plus b is pi minus c. So, this gives us pi by 2 minus c by 2. So, 4r cos c by 2, sin pi by 2 minus c by 2 is cos c by 2. So, this gives us 4r cos squared c by 2. So, 4r cos squared c by 2, or you can say that 2r into 2 cos squared c by 2. 2r into 2 cos squared c by 2 is 1 plus cos c. This is what r1 plus r2. So, r1 plus r2 upon 1 plus cos c equal to 2r. So, that is we have to get that. So, r1 plus r2 upon 1 plus cos c equal to 2r. So, now this is what r is the circumradius of a circle of the triangle, that is circumscribed triangle. So, now this 2r means always r1 plus r2 by 1 plus cos c equal to 2r. I hope the concepts and the questions are understood very well by you, and if you have any other questions, any other queries, you get back to us. Thank you.